Hello grade 8s. Today we are going to be going through the entire winter assessment memo. This is an examiner feedback video and this is part 1 of a series of videos that are going to go through the memo. There might be 2, there might be 3. Let's see how we get through each of the questions. As you can see on the front page, I've got the front page in front of you right here, and it explains it's 112 marks for 90 minutes. It's very important, grade 8s, that you read the instructions before you attempt the questions, so that you can just woosa and prepare yourself for writing the exam. Reading the questions for comprehension is very important, not just skimming the question. So please know that we are going to try and coach you regarding exam strategy, and it is going to get better as you get more and more used to the high school examination process. Let's look at the multiple choice questions over here. Alright, some people in the exam gave us more than one option for each question. Now, you need to know that we are going to only choose the first option that you write down. If you give me 2 or 3, it doesn't matter if the second one is correct. I'm only going to mark the first option that you write down. Let's look at 1.1. 1.1 has got to do with a safety card, and you had to choose which is the most accurate. Now, I know that the options that we've given you sound a lot alike. This is part of the examination process. It's part of the assessment process. We are trying to see, can you pick out the most accurate or the correct option? In terms of terminology, this was a terminology question, so we used terminology that was the same but not exact. If you look at question option A and C, they are very similar, but the difference is that C says not flammable and A says will not burn. You needed to choose, guys, you needed to choose will not burn. You needed to choose A. Alright, let's move on. Whoa, I think the computer is having a little moment. There we go. It's nice and highlighted as A. Moving on to the next question. The next question had to do with liquid volume in a measuring cylinder. Now, here you needed to apply what you knew about reading liquid volumes using the meniscus. And as you can see, all 3 are concave meniscus. And what do we do there? We always read from the bottom of the meniscus. The options that we gave you were very similar here. And it all boils down to decimal point. So I wanted you to be very exact, very scientific, and I wanted you to choose D, because it applies the correct decimal. Let's move on to another question that also plays around with definitions and terminology. The elves of Woodland Realm love crystals, and rose quartz is a precious gem. Can you see that I have given you the chemical symbol there? The chemical symbol is SiO2. That means that I've got 2 elements in this compound. The atoms are arranged in a regular, repeated, symmetrical pattern. Okay, right then and then you know that it's a crystal lattice because I've given you the definition. You know it's a compound and you know that it is a crystal lattice. The fact that I have no coefficients in front of my chemical symbol or my chemical formula tells you that I only have 1 molecule. So you would be tempted to choose C as the correct answer, okay? Because A and B have got element in it, and it's definitely not an element. You would be tempted to choose C, but the correct answer, the most accurate answer here is going to be D. Because these are applicable to rose quartz, which is a crystal. Question 1.4 had to do with scientific method. Now you needed to go back on what you knew about the scientific method and the scientific process, and how we build up a project or build up an experiment to figure out what the answer is. Because at the end of the day, what are we doing in science? We are trying to answer questions or solve problems. The options here, those sequences were shuffled around. And what's very important here, you needed to choose the one that said observation, because guys, that's the number one thing that we do first. We observe the problem, or we observe the phenomenon, and then we build a question. So this should have been a very simple question, should have been quite easy for you guys. The minute you saw question and hypothesis and interpretation, you would have known that it's wrong. And therefore, I wanted you to choose B as the answer. Question 1.5. Question 1.5 uses conversions and uses your formula for a triangle for surface area. So if you learned your scientific skills, if you applied your SI units, this should have been pretty straightforward. The trick was converting to centimeters squared. That was the trick. So I gave you quite a few options that were near, except for obviously D, it's completely bogus. D is bogus. But the other three are quite near to the correct answer. Remember, you needed to use your formula here to apply for the answer. So here, most of you got this right, so well done to most of you. And here, I wanted option A. It needs to be 0.06 centimeters squared. Question 1.6 has got to do with what is applicable to interpretation of data. We did this in your scientific method. We went through graphs, okay, and you were taught the different types of data and how we can apply those to graphs, or how we can use graphs as a tool to show the information that we have collected. This question was very tricky. If you did not read the question carefully, it would have been difficult for you. Remember, it's would not be able to use. Would not be able to use. That means that every option has to be correct for you to eliminate it. Remember, scatter plots and line graphs are used for relationship data. However, scatter plots, they are used for individuals, to see the individual participants or the individual occurrence. Here I'm looking at distance traveled over a month, so it's distance over time. What is the best graph for that? The best graph for that is going to be your line graph. So you can automatically eliminate B and D. Automatically eliminate B and D. The second best option, if you don't have a line graph, is to use a bar graph. If you don't have a line graph, even though bar graphs are used for categorical information, if you did not have a line graph, or you couldn't draw a line graph, a bar graph would have provided some sort of visualization of the information. So therefore, bar graphs are a second. So B, C, and D are incorrect, okay, right? They are, when I say incorrect, they can be used for this information. Option A, on the other hand, option A is definitely, you could not use these, because pie charts are off the table, because that represents fractions of a whole, and scatter plots is not in, histograms and scatter plots cannot be used for relationship data. So what I wanted you to do for relationship data of this type, what I wanted you to select is A. A would be the correct answer. Let's move on to 1.7. 1.7 shows, it refers to your flame tests. You guys needed to know 3 different flame tests. You needed to know the hydrogen test, the oxygen test, and then the carbon dioxide test. The specific test for carbon dioxide is the lime water test. However, another test that can prove for carbon dioxide is if a wooden splint is, the flame on a wooden splint goes out. But there are many different gases that can kill a flame or extinguish a flame. So that is not a specific test. The specific test is the lime water test. All these other options refer to the hydrogen test or refer to the oxygen test. So most of you guys got this right. So the correct answer here is going to be B. So what did we do here? For your multiple choice set you up for the rest of your exam. It warmed you up. It's like before you go exercise, that's what the multiple choice was. It was trying to get the thinking going, the brain cells working. Guys, if you read your questions carefully and you time yourself, I promise you this will not be stressful for you or at all if you've prepared. We are going to now move on to question 2. Question 2. Now this was quite application based. When I say application based, you had to use the information from your lab protocols as well as your acid and bases notes and to put them together to get the answer. The trick here is comprehension. Once again, we give you a lot of information and you have got to select the relevant information for the answer. Read carefully, read for comprehension, to understand. So, what are we getting from this paragraph? That there is, the story is that Ms. Orchard has run out of phenolphthalein indicator. She needs a new indicator, okay? So the experiment is to make red cabbage indicator using the materials and methods that are listed in the table in the method section, as well as looking at that diagram. So we gave you 3 different forms of data. 3 different forms of data to answer the questions that followed. This set of data here, the table of materials, deals with the apparatus. On the one side, you should all be familiar with this apparatus, and then deals with the chemicals used. Hydrochloric acid is a strong acid, but it's dilute. Dilute meaning it's weak, okay? It's been watered down. Concentrated sodium hydroxide solution means that it is a very strong a base. So concentrated means that there's a lot of the sodium hydroxide in a small amount of a small volume. Concentrated. Deionized or distilled water is pure water. I explained this in class. Pure water, which means that there has no overall charge. It has no overall ionization. It is 100% pH neutral. Okay, stable. This is maybe when you read these things, a good idea would be making give a keyword on the side. So you would have said weak here, you would have said strong here, and here you would have said pure. Just for yourself while you are reading the information. The next part of the question paper explains the method, explains that the water is boiled in the beaker. Then the pieces of cabbage are added to the water. Then you continue boiling. So what's going to happen to the cabbage while it boils? Guys, the water is going to change color. It's going to change color. Then you're going to turn off the Bunsen burner and allow the beaker to cool. This is part of lab protocol. And you are going to fill those test tubes with the solutions that I spoke about now within your chemical, the chemical column, and label your test tubes. Then you use your dropper to put in a few drops of your red cabbage solution and test in each test tube and note the cabbage solution, the color change of that solution in the test tubes. This diagram over here was very nice. This is a nice visual representation of what you have just read. We go to the questions now. Question 2.1. Question 2.1 was very easy. Most of you, it was very rare that people did not get 6 out of 6 here, which tells me that you have been studying your basic lab apparatus. So everyone got this one. If I go to my memo, you will see, here we go. Number 1 is a beaker. Number 2 is the water or the indicator solution. Number 3 is your red cabbage pieces. 4 is a wire gauze. 5 is a tripod, and 6 is a Bunsen burner. You could not say flame. If you said flame, that is incorrect. You needed to say Bunsen burner. So that was, I think, pretty straightforward from the book. That was an application. The second question asks to describe one precaution. Here, this is subjective. When I say subjective, if you gave me a reason that is from the book or that makes sense, I gave you the mark. The trick here was that I wanted you to give me the description. I did not just want the name, okay, or the listing. I wanted an actual description for 2 marks. A lot of you got 2 out of 2 here. So far, so good. Question 2.3. Now, here comes where I'm asking you to use your brain cells a little bit more and try and associate 2 or 3 different concepts together. It asks, what color would the test tube containing concentrated sodium hydroxide become if you added phenolphthalein to the test tube? Now, if you studied your indicators, you would know that phenolphthalein is going to go dark pink or magenta in a base. You know that sodium hydroxide is a base, so you put those 2 pieces of information together and all you needed to write was dark pink or magenta. If you said pink, I gave you the mark. 2.4 is again a safety question. Why is it important to label the test tubes as per step 5? Guys, again, deductive reasoning. This is common sense. Alright? You need to know what is in that test tube to stay safe in the lab, to make sure that your experiment works. So I put on my memo, I wanted you guys to say to avoid an accident, as well as to not mix up solutions. What if you make a mistake and you mix up solutions and you don't know exactly what's in that test tube? So for 2 marks, most of you got this right, which tells me that first term went really well for you. For 2.5, what pH would you expect deionized water to have? Now, this is directly from your book. We explained to you already what deionized water is. It's the same as distilled water. It's pure water. What is pure water based on your pH scale? It is 7. It is 7. So I would have wanted you to go and say that it is going to be 7, so that's the pH, and then I wanted you to explain by saying that 7 means it is neutralized. It's a neutralized solution. The key word here would have been neutralized. Question 2.6. Question 2.6 has got to do with the expected color changes of red cabbage with pH. Here, all you had to do was look at the chart and answer the questions that followed. So I thought this was direct. There wasn't much application here, but you needed to know the pH of these solutions, hydrochloric acid, sodium hydroxide, and pure water. You needed to know around where it would be, a range. You know that hydrochloric acid is a strong acid. You know that sodium hydroxide is a strong base, and you know that pure water is neutralized. These were 3 very easy marks. Grade 8s, very easy marks. So I wanted here light pink or red, not dark pink, light pink or red. So here there was a lot of leniency, there's a lot of wiggle room, but if you didn't refer to a color that was on the chart, you didn't get the mark. For your sodium hydroxide, I wanted aqua or green. Even if you said yellow, you got the mark. And then for your pure water, I wanted purple blue. So 3 easy marks here. 3 very easy marks. Okay, let's go to 2.7. 2.7. Now we are moving more into application style questions. I want to know what you guys think, grade 8s. I'm not just throwing facts at you and asking you to regurgitate them. I want you to know that you can think critically and you can put an argument together. So, purple layer powder dissolves in water to make purple layer solution. Explain why you think it would be difficult to use the red cabbage indicator to test the pH of the powder. This goes back to the boiling of the cabbage. If you're boiling something, especially a substance that is going to, think about carrots. When your mom boils carrots on the stove, what happens? The water goes like an orangey yellow. The same goes for cabbage. Vegetables of color are going to change the color of the water when they are boiled. So now the red cabbage, the water is going to become like a reddy purple color. So if you use a pH indicator, that is specifically designed for color changes, and you put that in a red purple solution, you are not going to get an accurate result of the color change. It is not going to be representative of the pH. So if I go to my answer here, right, I wanted you to explain that you would not be able to identify, or you cannot see the color change for 2 marks. So give me 2 reasons why you would not. You would say that the purple layer solution would distort any color changes, therefore you would not be able to see the color change of the indicator. 2 marks. Question 2.8. Question 2.8 asks you to predict which specific products would form if sodium hydroxide and hydrochloric acid are reacted together. This goes back to your general word equations. You know that if a metal hydroxide and an acid react together, you are going to get salt and water. I wanted the specific products, not the general products. If you said salt and water, that is incorrect. You didn't have to say, okay, dihydrogen monoxide. You didn't have to say that scientific term for water. You can use the common word for water at this level. It's fine. All I wanted was here, I wanted you to say sodium chloride because the metal, remember, the metal bonds to the chlorine. The hydrochloric acid breaks apart and the hydrogen is expressed, or hydrogen is liberated. Hydrogen gas is liberated in the reaction. So for 2 marks is sodium chloride, that's your salt, and water is going to be your second product because of the hydroxide. Because there's excess hydrogen, there's excess oxygen, they bond together, they form water. The last question for this section, and then we're going to stop this video and then I'll make another video for question 3 and 4, is got to do with a pH. Now this was directly extension. I said this in the class and I'm going to say it again. Here I wanted you to use the knowledge that you had from your book based on pH indicators and apply it to this extension question, which introduces you, and I'm sure I told my class about pH meters. It introduces you to pH meters, so you've got to put 2 pieces of information together and make up your mind, okay, on what you think is who is correct here. Let's read. It says a pH meter is an electrical device used in labs to measure hydrogen ion activity, so whether something is acid or whether something is a base in a solution. It provides a numerical value. Now, in science, there are 2 different types of data: qualitative data and quantitative data. Qualitative data tends to be very subjective, whereas quantitative data is very objective and more precise. So numerical value, which corresponds to the pH scale. I've said to you guys before, one of the drawbacks of pH indicators is that it gives us a range. It doesn't give us a specific value. Therefore, the pH that you are reading is not exact. Jana says that both indicators and pH meters are equally reliable in determining the accurate pH of a substance, because all indicators and pH meters can measure across the entire pH scale. Arabella says that indicators are the most accurate, but they cannot be used for testing gases. So this was your information section, and then here was your instruction. You had to identify their mistakes and explain why they were wrong. So for 2 marks, you have to identify the mistakes, and for another 2 marks, you have to explain where they're wrong. So let's look at the memo. These are the options that I wanted you to say. If you said one of these 2, you were fine. I mean, sorry, one of the 2 for each girl, you were fine. Excuse me. Jana, both indicators and pH meter are reliable? No. Yes, they are, but the pH meter is the most accurate. Indicators only represent a range, not an exact value. That would have been an explanation. Indicators are the most accurate,
No, they are not the most accurate. Arabella's wrong. pH meter is more accurate. So that would have been your explanation or correction. And indicators can test gases. That's incorrect. Okay. So please have a look here. Please have a look here at these options here. But yes, this was an extension question. This was pushing you guys a little bit at the end of this section. That is it for today. Okay, or that is it for this video. The next video is going to cover question 3 and 4, and then the following video will cover the rest of the exam.